Hello wonderful person, this is Anton, and today we're going to discuss yet another unusual mystery involving a vanishing star, but in this case a very bright star in the nearby Andromeda galaxy that suddenly disappeared not so long ago. And here this is a really bizarre discovery because this star, 13 times the mass of the Sun, was extremely bright for a very long time, but then suddenly completely disappeared with no explosion, no fireworks, and just a kind of a quiet transition into complete darkness. And though based on its mass, we do expect stars like this to create a relatively bright supernova at some point, in this case that's not what the scientists observed. And based on some of the recent research, there is potentially now a very exciting explanation involving a somewhat intriguing phenomenon. And so let's discuss this particular study by De and the team you see behind me, focusing on the explanation and all of the evidence behind this, and what researchers currently believe very likely happened here. And so today we're going to discuss this remarkable discovery involving a star known as M31 2014 DS1, which seems to present us with the clearest evidence that sometimes stars don't go supernova, but instead go through a kind of a failed supernova, turning into black holes directly, which is really the only way we can explain such a very strange and very sudden disappearance. But this is something astronomers expected to happen sometimes. And so for decades, a lot of astronomers theorized that not every massive star should go supernova. But we do expect pretty much all stars, more massive than approximately 10 masses of the Sun, to essentially transition into something after a few million years. But so far, pretty much all of them have basically created supernova. But there have been a few models predicting that sometimes the supernova can fail. And in this scenario, the core of the star still collapses, but the resulting shockwave is just not strong enough to blast the rest of the star into outer space. And instead, the material that was supposed to be released falls back, and the entire star is then suddenly swallowed by the newly formed black hole. But the problem is that this was pretty much entirely hypothetical, and these events would be very difficult to prove. Mostly because we have to find a star that just kind of disappears, but on top of this, then find evidence that there's either a black hole left behind, or that there was something going on here, and there was some kind of a failed supernova. And moreover, if there is no explosion, how do you even notice a single star disappearing? And that's actually one of the reasons this particular study is kind of exciting. And so here, De from Columbia University dug through years and years of archival data, mostly focusing on NASA's NEOWISE mission and a few other telescopes. And here the focus was on discovering vanishing stars. And at least one of these objects seemed to do just that. In 2014, there was a star that you see right here that suddenly started getting brighter and brighter in the infrared light, increasing in overall luminosity by approximately 50%. But between 2016 and 2022, it seemed to dim dramatically, eventually completely vanishing from visible light. And by 2023, or just a year after, the total energy output seemed to have dropped by at least a factor of 10. Or basically there was still something here, but it was no longer the same star. But more importantly, the additional observations here reveal that the star is not just hiding, but it seemed to have stopped shining because it was no longer producing nuclear reactions responsible for the production of energy. Or basically that the core in this case seems to have ceased to exist. But to understand what's happening here, we have to take a look at the failed part of this supernova. And so normally, when any massive star runs out of fuel, its core starts to collapse into a dense object. This sends a massive shock moving outwards. And so in this particular case, this particular shock seems to have stopped or stalled for some unknown reasons. And instead of ripping the star apart, all of this material started to return back into the center, where there was now a newly formed black hole. And a black hole that was now consuming a lot of mass. But this was not some kind of a sudden gulp. All of this was a relatively slow process, and on top of this, at least 1% of the stuff, or at least 1% of the outer layer, was still pushed out, creating a kind of a shell of dust that then began to glow in the infrared. And in this case, it was actually this infrared increase that was predicted by theories back in the 1970s. And so in this case, the observations seem to match predictions from the 1970s in regards to these failed supernova. But the additional observations also reveal that convection, or the way that the hot gas moves inside the star, seems to have played a relatively large role. Or essentially because the gas was swirling so much inside the star, it did not start returning into the black hole all at once. And instead, this was a very slow process, taking years, which is why for 3 years, researchers observed this bizarre infrared glow. And it was only after 3 years that all of this kind of disappeared. But intriguingly, this is possibly not the first time we've actually observed this. As a matter of fact, the first time was maybe this. A suspected failed supernova from back in 2010, but in this case from a galaxy approximately 22 million light-years away from us, NGC 6946. But in this case, since this was at least 10 times as far, the data was not as good. And so some scientists debated that maybe this was actually a merger of two stars and not a birth of a black hole. Nevertheless, this is still believed to be maybe a black hole, and so there's a chance that we've seen this at least twice. But with this new discovery in the Andromeda galaxy, the evidence is very, very strong. And so by comparing the two observations, astronomers are now starting to realize that there are certain patterns that seem to be common to both of these events. Basically suggesting that this is a kind of a new class of events that we most likely missed before because they're just not very visible and do not produce these very typical bright explosions. And so here we have a kind of a quiet black hole formation, which might be actually quite common since we've now observed two in just a decade. And this can also explain another mystery. The mystery in regards to not seeing as many supernova events as researchers predicted. And so quite a few of these supernova events potentially just fail, resulting in direct collapsed black holes and not supernova explosions. But obviously because regular supernova produce extremely bright explosions, they're much easier to find and thus present us with a kind of a bias. And so here the next question would be, okay, so in terms of actual numbers, or I guess in terms of ratio, what proportions of supernova actually go to the completion and how many percent usually fail? Because by figuring this out, we can then discover how many black holes could be hiding in the entire galaxy, as quite a few of them could have formed in a very similar way. But in this case, I guess the shocking part about this study is that up until recently, for approximately 5 years, nobody had any idea that this even happened. Mostly because this event basically happened without any fanfare. The star just disappeared, and disappeared relatively slowly. But in the last few years, researchers did discover a few more candidates that still have not been confirmed yet. Or basically this is the first confirmed case, but we do have some cases that could have also happened in a very similar way. For example, we have an object known as M101 OC1. This was a blue supergiant star located in the Pinwheel galaxy that might have also gone through something very similar. This was reported in the study. But in essence, here we also had a star that rapidly dimmed in the optical wavelengths based on 11 years of observations. And right now it's not entirely clear what actually happened to this star, but this is the other potential candidate for a direct collapsed black hole. Then we have NGC 3021, candidate 1, from the spiral galaxy NGC 3021. Here there was a massive yellow supergiant that also vanished from optical observations, indicating a possible failed supernova. But because this is quite far away, 93 million light-years away from us, it's a little bit difficult to find more evidence. Either way though, this was reported in a study right here, with the images as you can see, once again showing something vanishing. And then we have M51 DS1. DS stands for Dimming Star, a massive red supergiant in the famous Whirlpool galaxy that also experienced an extremely deep fading event between 2017 and 2019. But in this case, this particular star seems to have rebrightened a little bit, and so there are possibly other explanations, including some kind of a very intense dust formation event that possibly just hit the star. This was reported in a study right here. And so this particular event seems to be entirely different, or at least seems to resemble something we've never seen before. Because here the star did vanish, but then seems to have reappeared. And that of course means that even the current models we have are still incomplete. Mostly because we have no idea which stars explode, which don't, and which seem to go through something entirely different. But based on these observations, it does seem like the gravity, gas pressure, and even shock waves seem to interact in some very unpredictable ways, and seem to create effects we cannot explain. But because in this case, the remnant for this particular star is still actually kind of visible, glowing faintly in the mid-infrared light, it means that in some of the future studies, telescopes like the James Webb might be able to tell us much more, and even tell us how all of this evolves, and if it actually did form a black hole in the center. For now though, this definitely seems to be the best example for these failed supernova that essentially result in the formation of a typical black hole. In this case, one that seems to be at least 5 times as massive as the Sun. But we'll definitely come back and discuss this more in some of the future videos once there are some future updates. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can damage directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.